In this lesson, we look at exponential functions and their graphs. Recall that an exponential function is simply a function that has a variable as an exponent. And all graphs of exponential functions have certain characteristics in common, and it's these characteristics that allow us to easily graph any basic exponential function. So let's look at those characteristics. And I'm talking about the basic exponential function that has no translations or transformations at all, just the basic. So I'm going to go through each one of these and show it to you on a graph. But just to start, let's look at all of them together. Whenever a is greater than 1, your function is going to be increasing. Whenever a is between 0 and 1, so some fraction between 0 and 1, your function is going to decrease. The y-intercept is always 0, 1. And again, that's if there's no transformations or translations. The graph has the x-axis as the horizontal asymptote. The domain, -infinity to infinity, so x can be any value. The range is 0 to infinity, so we see that we're not going to get any negative values for our y-coordinates. And this is a one-to-one function. So let's look at each one of those individually. First of all, the increasing and decreasing. I've got two functions on here. Let's look at f of x is equal to 2 to the x power. So focus on the blue curve. A function increasing means that as you're moving from left to right, that curve is going upwards. So whenever a is greater than 1, you have an increasing function. Let's look at the decreasing. F of x is equal to 1/2 to the x power, so a is 1/2, so it's between 0 and 1, which means our function is decreasing. That means as we move from left to right across our function, our curve is heading downwards. Another characteristic is that the intercept of the graph is 0, 1, and you can see this is true for both this increasing function and the decreasing function. So again, as long as there's no translations, your y-intercept is always going to be at 0, 1. Another characteristic we looked at is that the graph has the x-axis as the horizontal asymptote, and you can see visually that that's true. The domain of all of these exponential functions, -infinity to infinity, so x can be any value. The range, you can see again, we're not going to cross down into the negative coordinates. There's no way that you're going to generate a negative value from these exponential functions as they're written here. And finally, the function is one-to-one. So let's remember what one-to-one means. In fact, let's look at the two tests. The first test, recall the vertical line test. The vertical line test tells you whether or not you have a function. So as you move a vertical line from left to right across the curve, it should not touch the curve in more than one place. So if that's true, we have a function. Now to test to see whether it's actually a one-to-one function, we use the horizontal line test, which says move a horizontal line up or down, doesn't matter which way, along your graph. And if it does not touch the graph in more than one place, then your function is one-to-one. So 6 basic characteristics help us to graph any basic exponential function. Let's take a look at how we would graph f of x is equal to 3 to the x power. There's already a couple things that we know that will allow us to quickly sketch a graph. This is just a complete sketch. We know the graph is increasing. We've seen what the basic shape of an exponential graph looks like, and we know the y-intercept is going to be at 0, 1. So there you go. I've just sketched a graph. We also know that there's a horizontal asymptote at y equals 0, and recall that the range starts at 0 and goes up, so we're not going to cross the x-axis. What we don't really know is how wide this curve is. So we need to plot some points to see how wide that curve is going to be. So let's plug in a -1 for x. Doing that, we get y is equal to 1/3. Let's plot that point. Well, that's pretty close to what we sketched. Let's plug in a -2 for x. We end up with 1/9. Again, not too far off. And finally, let's put in a positive value, f of 1, 3 to the first power is equal to 3. Well, that's kind of off our grid there, but nonetheless, there's that point, and it looks pretty close. So just knowing these basic characteristics, you can actually sketch a graph and get pretty close to what it looks like. And using a graphing app, here is what that graph looks like, and you can see that we got awfully close just knowing the basic characteristics, and it didn't take much work at all to figure it out. Now, once you start getting some translations and transformations in there, that graph might look a little bit different, but we'll cover that in a different lesson. So remember that a basic exponential function has a variable as an exponent, and that all graphs of these functions have certain characteristics in common, and we looked at those characteristics.